So hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. Welcome. Today we delve into Mirage AI, an innovative model using visual thinking to solve problems. It mimics human imagination, excelling in spatial reasoning and planning. Really well explore its unique visual approach and future potential. What inspired the development of the Mirage AI model, and how does its approach to visual thinking differ from traditional AI models that rely on generating external outputs? So,
the development of the Mirage AI model was inspired by the idea that just thinking visually can be a more natural and efficient way to solve problems, similar to how humans create mental images when they think. So traditional AI models often rely on text and code to process information, which can be slow and cumbersome, much like trying to build a Lego tower without really seeing the pieces. In contrast, Mirage is designed to truly think, like visually, allowing it to create mental images just like you do when you think about something familiar like your mom. So this means that instead of just generating words or drawings to express its thoughts, Mirage uses visual cues to understand and solve problems. It's like having a special toolbox that helps it see the solution right away rather than just having to describe it, step by step. So this approach suggests we're indeed moving towards spatial aware AI, as Mirage can understand and manipulate visual information in a way that is more akin to human thinking. So this could potentially make AI more intuitive and effective in tasks that require visual reasoning.
What specific methods were actually employed in training the Mirage model with its unique visual dataset? And so how do these methods enhance its ability to leverage visual cues compared to other latent reasoning models?
To train the Mirage model, researchers used a pretty unique visual dataset that included helper images which were specially annotated by humans. This means that the model had specific images to look at while actually learning, guiding it on how to solve problems using visual cues. Imagine teaching someone to ride a bike by showing them pictures of how to balance and pedal instead of just telling them how to do it. So this training method enhances Mirage's ability to leverage visual cues because it really forces the model to focus on visual information when solving problems. While other models might get distracted by text and struggle to think visually, Mirage is designed to recognize when it actually needs to think visually. It generates a special signal that tells it to switch into this visual thinking mode, allowing it to work directly with the images before returning to text for communication. So, the effectiveness of this approach was demonstrated through an analysis that showed how the model's new visual thoughts were closely clustered with the images it was trained on. So, unlike traditional models that often spread their thinking out across a wider range of text-based ideas, so this clustering indicates that Mirage is truly learning to process and understand visual information in a more coherent and efficient way, so leading to significant improvements in tasks that require spatial reasoning and planning.
Could you elaborate on the specific improvements in spatial reasoning and planning capabilities that have been observed in the Mirage model, and so how these improvements were measured or demonstrated in the study?
The Mirage model has shown significant improvements in spatial reasoning and planning capabilities, which means it can better understand and manipulate space and objects within it. So these improvements are measured through specific benchmarks designed to assess how well a model performs tasks that require understanding spatial relationships, just like figuring out how to arrange objects or navigate through a space. One way these improvements were demonstrated is by comparing Mirage's performance to that kind of traditional AI models. While other allies might try to solve spatial problems using text-based reasoning, like treating them as written math problems, Mirage uses visual cues from its training. This means it can recognize important details in images, so much like how you would look at a map to find your way instead of just reading directions. The model was trained to know when it should think visually by generating a special signal that switches it into a mode focused on spatial reasoning. So once it finishes this visual thinking, it can then return to communicating through text. This two-step process helps ensure that it fully utilizes the visual information available to it before summarizing its thoughts in words. So overall, the improvements were evident across various tests, showing that Mirage's approach to visual thinking not only makes logical sense, but also leads to better performance in tasks requiring spatial understanding.
What kind of implications do the findings about the Mirage model's visual thinking capabilities have for future developments in AI technology? particularly in fields that rely really heavily on spatial reasoning, such as robotics or architecture.
The findings about the Mirage models, visual thinking capabilities have really exciting implications for the future of AI technology, especially in fields that depend on spatial reasoning, like robotics and architecture. Since Mirage can create mental images and truly think visually, it means that future AI applications could better understand and interact with the physical world. So, for example, in robotics, this could lead to robots that can navigate complex environments more effectively, just kind of like finding their way through a crowded room or assembling furniture by visualizing the best way to fit the pieces together. So imagine a robot that can look at a room and decide where to place furniture by visualizing how it will fit rather than just following a set of instructions. In architecture, designers could use AI like Mirage to visualize buildings and spaces before they're built. So this could help architects see how different designs would look in real life, allowing them to make better decisions about layout and aesthetics. It's like having a virtual sketchpad where the AI can help brainstorm and visualize ideas before any kind of construction begins. So overall, the advancements in spatial reasoning demonstrated by the Mirage model suggest we're moving towards a new era of spatial AI, which could actually transform how we design, build, interact with our environment.
So how does the ability of Mirage to switch between visual thinking and text-based communication enhance its overall functionality, and what challenges might arise from this dual approach in practical applications?
The ability of Mirage to switch between visual thinking and text-based communication enhances its overall functionality by allowing it to utilize the strengths of both approaches. So when it needs to solve a problem that involves spatial reasoning, it can actually generate mental images to visualize the situation, which helps it understand and analyze the problem more effectively. Once the visual thinking is complete, it can then express its findings through text, making it easier for humans to understand the solution. Like this dual approach is like having a toolbox with different tools for different tasks. So it allows Mirage to be more versatile and effective in a variety of situations. However, challenges may arise from this dual approach in practical applications. For instance, the transition between visual thinking and text communication could introduce complexity. If the model doesn't switch smoothly, it might lead to confusion or miscommunication, especially if the visual insights are not clearly articulated in words like. Additionally, there may be instances where the model struggles to generate the right visual cues or interpret them accurately, which could actually hinder its performance. Furthermore, relying on visual thinking could be slower than text-based reasoning, which might frustrate users who expect really quick responses. Balancing the efficiency of the two modes while ensuring clear communication is a key challenge that developers will need to address as they implement Mirage in real-world applications.
So what kind of future research directions do you think are essential for further advancing the capabilities of models like Mirage, particularly in enhancing their visual reasoning and communication abilities?
To further advance the capabilities of models like Mirage, so several research directions are essential, particularly in enhancing their visual reasoning and communication ability. One really important area is the development of more comprehensive visual dataset by creating larger, more diverse collections of helper images, so researchers can provide the model with a richer set of visual cues to learn from. This could help improve the model's ability to recognize and interpret different spatial relationships and contexts. Another direction is refining the model's ability to switch between visual thinking and text-based communication. Research could really focus on optimizing this transition so that the model communicates its visual insights more clearly and effectively. This might involve developing better algorithms that ensure seamless integration between the two modes of thinking. Additionally, exploring ways to enhance the models like imagination capabilities would be beneficial. So instead of just relying on existing images, future research could investigate how to enable models to generate new visual ideas or scenarios based on learned concepts. This would be akin to how humans can think of new things that they haven't seen before, which could significantly expand the models, like creative potential. Lastly, examining how models like Mirage can interact with users in real time could actually lead to improvements in practical application. Research could focus on making the communication process more intuitive, allowing users to engage with the model in a way that feels like natural and productive. By pursuing these directions, researchers can build on the foundation established by Mirage and create even more powerful AI systems that excel in visual reasoning and communication,
Well, that brings us to the end of another really fascinating discussion. Just a huge thank you to our expert for sharing such insightful perspectives on the Mirage AI model. What we've explored today really truly highlights a groundbreaking shift in artificial intelligence. The Mirage model at its core is designed to enhance problem solving just by embracing visual thinking, much like our own human minds utilize mental imagery. It moved beyond conventional AI approaches by generating these internal visual studies to understand and tackle tasks, fostering a more intuitive path to visual reasoning. We learned that its really remarkable capabilities stem from training with specialized visual datasets, complete with annotated helper images, which allows it to deeply focus on visual cues. This targeted approach has led to really significant advancements in its spatial reasoning and planning abilities. While this dual capacity to navigate between visual thought and textual communication greatly expands its functionality, it also presents really interesting challenges, such as ensuring seamless transition. Looking ahead, the path for models like Mirage involves expanding these crucial visual datasets, refining the seamless switching between thinking modes, boosting its imaginative capacities, and enhancing real-time user interaction. These advancements are so key to unlocking its full potential in critical fields like robotics and architecture, where precise spatial understanding is paramount. So thank you all for joining us for this illuminating conversation. So we look forward to seeing you next time.